regularly to work in this room, so I sent an email to one of our computer people. That's what he was doing. He was fixing it this morning from remote. I thought he had to come over here, but no. He just fixed it remotely. All right, so this is, you guys have that displayed to your computer if you're in Nearpod, DKCWM. So this is, if we're adding, what we're doing is if we're going to add D, this is on the outside of the function. If the transformation is on the outside, it changes Y, and it changes it in the direction you would think. A positive D shifts it up, and a negative D shifts it down. The constant D causes a vertical shift in the graph. So is that, oh, it's right there on our slide. The shifts result in graphs oscillating about the horizontal line y equals D instead of y equals 0. Or the x-axis. And the maximum value of y will be D plus the absolute value of the amplitude. Of A. It'll be D plus the amplitude, which is the absolute value of A. The minimum value will be D minus A. Okay?
So we're going to do an example. So that's the slide you're all seeing. We're going to do this example. And I'll be switching back to bring it up. We're going to graph one period of y equals 2 cosine x2. 2. Plus 1. Sorry. I told you. I'm sleeping. Sorry. All right. So this is a vertical I'm trying to stretch. I don't know if that was the right word. I'm not. There we go. And we're adding one on the outside. Notice there's no parentheses around. We got just cosine of x. And we're adding on the outside, so that's a shift up 1. In this example, so we have to identify the amplitude. Well, and the amplitude is the absolute value of A, which is 2. The period is pi over b, and it may be helpful to write here. This is y equals a cosine of bx minus c plus d. That's the standard form. This is what we're working with. B is the number in front of the x. So b in this example is 1. So that's 2 pi over 1 is 2 pi. Our period is 2 pi. There's no phase shift because 0. C is 0 because we're not subtracting or adding inside the cosine function. So there's no phase shift. Phase shift was B over C.
but there's none. And so, and our period's 2 pi, vertical shift, so we've talked about all those shifts, so now we're on the next slide.
And it's not like we're dividing by C is 0, then they're, oh, I think I got that upside down. Oh, it is. C over B. I have it here. I don't know. It's C over B. See?
We don't really need that in this example, but I put it upside down. I left my field of notes in my office, but okay. Sorry about that. Dear. Okay, so going back to the slideshow, and we're going to go to the next slide. And so we're going to find the 5 key points for X. And we're just going to make a table. It's going to be X, Y, and so our 5 key points, because there's no phase shift, X1 is just going to be 0. Okay? And then you take your period and you divide it by 4. The period, this is important to remember, you take the period divided by 4 is 2 pi over 4 is pi over 2. And that's what you add to the 0. So for X2, it's going to be 0 plus pi over 2. And that just equals pi over 2. And then you continue adding pi over 2. So you got X3 is pi over 2. It's the period divided by 4 plus pi over 2 is pi. I'm switching colors. So this is the period over 4. And X3, guess what that's, X4 is going to be the previous value of X, pi, plus another pi over 2. That's 3 pi over 2. And the last one, and since, you know, this is, if you know these, you don't have to show all these out, but 3 pi over 2, this is just the same 5 key points as a regular sine function. Because there is no, B was 1 and C was 0, so, and we get pi. Oh, cosine function, sorry. So let's write what the cosine function, let's write cosine of X first, right here. Okay, and then we're going to write y equals 2 cosine X plus 1. Okay, so if you're thinking about your unit circle, cosine on the unit circle, these are the 5 key points. Here, 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 and then here again. And cosine, the x coordinate is cosine x. The x coordinate. So this is 1, 0. So at an angle of 0 radians, the cosine is 1. Up here is, we're at 0, 1, and so the cosine of pi over 2 is 0. Here we're at minus 1, 0, so the cosine of pi is minus 1. And here we're at 0, minus 1, so cosine of 3 pi over 2 is 0. And then back to here for oh, I'm sorry, this is supposed to be 2 pi. Yeah, 3 pi over 2 plus pi over 2 is 2 pi. And that's back to here. And cosine is 1. So we've got y equals 2 times cosine of x, which is 1, plus 1, whoops, I want to do different colors. So that's 2 plus 1 is 3. So we're going to have 2 times plus 1. 2 times 0, that's the cosine function. And that's going to be 1. 2 times a negative 1 plus 1 is going to be, that's negative 2 plus 1, that is negative 1. And 2 times, we'll put in 0 again, plus 1, it's going to be 1. Are you following this? So 0, just putting that value in there. And 2 times 1 plus 1 is 3. We got to put this 1 in here. Okay, so we have this graph. We're going to graph it now. I guess I'll catch up on the slideshow here a minute. So the slideshow, that was the 5 key points. And they did it a little differently than me, but very similar. They actually put the cosine function right into there. And you can do it this way too, whichever way you think makes more sense. So we get the point 0, 3, pi over 2, 1, pi, negative 1, 3 pi over 2, 1, and 2 pi, 3. We got the same point. And then we're going to graph it. This is just showing a vertical, it's showing an amplitude of 2 and a vertical shift of 1, and what happens with the cosine. So we got the point 0, 3. Let's see. I guess we'll need to mark off, pi over 2, pi, 3 pi over 2, and 2 pi. And then we need to go up to 3. We'll show 1, 2, 3, 4. And trying to make equal marks. And I guess I'll just draw it. Let's see. I'll draw it in blue just to show it, just be different than what I marked it with. Okay, so 0, 3, pi over 2, 1, pi, negative 1, yeah, that's cosine. 3 pi over 2, 1, and 2 pi, 3. And it's a smooth curve. this is y, 1 period of y equals 2 cosine x plus 1. Okay? Now if we want to draw the regular cosine function, it would be here, 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 and here. The regular cosine function here. Okay? Okay, and now we got one more example. Are you still copying? Making sense? The building no colors. Okay. All right. Okay, so we're going to do a word problem now. Yay, word problem. A region that is 30 degrees north of the equator averages a minimum of 10 hours of daylight in December. Hours of daylight are at a maximum of 14 hours in June. Let X represent the month of the year, with 1 for January, 2 for February, 3 for March, 12 for December. If Y represents the number of hours of daylight in a month, use a sine function in the form Y equals A sine of Bx minus C plus D to model the hours of daylight. So, this is, do I really? Section 4.6. I have section 4.6 now. Okay. Well, so we've got the hours of daylight range from a minimum of 10. So hours of daylight range from 10 to 14. And so that means it's oscillating about 12. So that means that D equals 12. So that's what it's going to oscillate about the middle value between 10 and 14. And that's what the slide shows. Says, so D is 12. Oh, and they keep repeating the problem. So the maximum number of daylight is 14, which is 2 hours more than 12. So A, the amplitude is 2. So A has to equal 2. We're going to be oscillating about 12, and so A can't be 1. We'd only get up to, go down to 11 and 13. So A has to be 2, because that's 12 minus 10. Or 14 minus 12. Wait, A has to be 2. Okay, so our period, here's the next slide. Our period equals 2 pi over B. And our period occurs over 12 months. So 12 equals 2 pi over b. So we're going to solve for b. So we can write this as 12 over 1. Cross multiply. We're trying to find all the values here. A, B, C, D. So we get 12b equals 2 pi. Divide by 12. So b is pi over 6. So we've got B, we've got D, and we've got A. Now all we need is C, right? If we get A, B, yes.
How'd you get pi 6?
I took 2 divided by 2 is 1, and 12 divided by... Did you miss this step? It's
Well, I did that, and then I got where you got 12 pi b over 12, but where did 2 pi over 12 come from?
Oh,
That's what I'm
Oh,
confused about. 'Cause wouldn't that just be...
this is
B.
12b equals 2 pi. I cross multiplied. 12b equals 2
Oh,
pi
I
times
see what I
1.
did. I added, for some reason, I put the 1 with my 2.
Okay, and
I see
so
what I did wrong.
it's 1 times 2 pi, so I just wrote 2 pi. That's okay.
Thank you.
Get it. You're welcome. Okay, so, and that's where, so you didn't see where the 2 pi came from. Okay. So we cross multiplied over here. And it's 12b equals 2 pi times 1, and that's where I got this. So, if you missed that step, then somebody else did too. Here.
Well, I was looking at the filled in notes you have on here on D12, and you got 12b over 12 equals 2 pi over 12, then it says b equals pi over 6.
Yeah, yeah. And
So I was confused as where the 12b over 12 came from. Because
Yeah.
I was trying to follow along with these, what you got there.
Right, right. I may not have shown the cross multiplying.
You did right above it.
Okay, okay. Well, yeah, but yeah, that's fine. So now you see where it comes from.
Yeah. Can you read this real quick?
Yeah, I forgot what filled in notes, but
Yeah, these ones you get on these moves. So this right here is exceeding cross multiplication.
12b equals 2 pi. 12b equals 2 pi times 1. So that's where I got 12b. I got 12b equals 2 pi from cross multiplying.
Okay,
And then the 12 came from because 12 times b, in order to get b by itself, you need to divide by 12.
I got it. Okay, that makes sense. Thank you.
Okay, okay. So I think it probably helps to go ahead and write this up here, that you cross multiplied, and you got this, because, you know, you're seeing the next step on the filled in notes. Okay. So that's our B, and so now, the starting point of the cycle is March. And let's see, our new filled in notes explain why that was March. Because it's a sine function, we said it was. But anyway, so x equals 3. Our starting point, so it explains it, let's see, let me show you. I've got the new note in Shobi. It's probably not going to remember the sign in. I'm surprised it is. Seems to be. Okay. So I just wanted to pull up the new notes. They've updated these notes that I captured before. So they have one more slide here that I thought was nice. What slide? So, is it the same? No, this looks like the same exact thing, doesn't it? How can I skip to page 50? I think it's the same. Never mind. Well, anyway, it said because we're doing the sign function that, okay, I'll write it down. Why do we start? We start with March. And I guess I need to March x equals 3 because it's the sign function, and it tells us in the problem hours are at a maximum of 14 hours in June. And a minimum of 10 hours in December. So we got to go halfway. The starting point has to be starting at zero. Well, we got to start halfway between December and June. So x equals 3 is halfway between June, which is, I don't know, June is the 6th month and December is the 12th, but we're starting with 12 and going to June. Halfway, March is halfway. And it's the sine function, so it's looking like this. So we gotta start here at x equals 3, go to a minimum here. Oh, wait a minute. We have a minimum in, a max in June, sorry. We got to start at 3 and go to a maximum in June, which is 6. And then this will be 9. I don't know if I can add still. The max is in June, and the next thing is the minimum's in December, 12. So that's December. This is the sine function. That's December. So that's how you kind of have to draw the graph, I think, to figure that out. If you've got a maximum in June and a minimum in December, where do you got to start this thing? This is what sine looks like. So you got to go up first and then down. So we had to go there. So let's go to the next. So we got to find the phase shift now. So we know that 3 is the starting place, and that equals the phase shift, which is C over B. Well, we know that B is pi over 6. So that's C divided by pi over 6 is C. Oh, and that's times 6 over pi is 3. Okay? And then we're going to, I could have just multiplied by pi over 6 instead of doing all that work. We want to get, we could have multiplied at this point by pi over 6. We want to get C by itself, and I probably did it less complicated way in the filled-in note. C is 3 pi over 6 or pi over 2.
I thought when you do that, you have to flip it, so it would be C times 6 over pi, right?
Yeah, but I did flip it, but then I had to get C by itself, so I had to multiply by the reciprocal. So, I mean, maybe I could have just started here with 3 equals C divided by pi over 6. To get rid of the pi over 6, we just multiply by pi over 6 over 1. So I made it much, I didn't have to go through all this flipping, really. I think this would be better. And if you have it like this, that's just C, which is pi over 2. So don't do all this extra flipping, I don't know. I'm not looking at my notes. I probably didn't do all the extra flipping, did I? No.
By the seams of it.
No, probably not. Okay, so the phase shift is pi over 2. Now we have everything to write the equation. So the equation, again, it's y equals a sine of bx plus c, minus c plus d. So y equals 2 sine b was pi over 6 x minus pi over 2 plus, and d was 12. That's our equation that models the behavior of hours of daylight. Okay, that's the end of section 4.5. So let's look at this for a second. You have to, this is homework, so I'm going to try to help you with it. Did you write all that down? This is a silly note. This is your problem. So you want to write down y equals a sine of bx minus c plus d. And you have, notice they factored out, this is actually, they've actually factored out, so let me factor the b out here. A sine, if you factor your b out, you get x minus the phase shift plus d. So because they factored this out, guess what 2 pi over 365 is? That's it here, b. So this is b. Guess what 79 is? C over b, our phase. The 12 is D, obviously, and the 3 is A.
Period's 2 pi.
And the period is 2 pi over B. So yes. So right. So you have to find your period as 2 pi over B. And B is 2 pi over 365. So when you flip that, it's 2 pi times 365. No, it's 2 pi. So the period isn't 2 pi. These cancel. The period is 365 days. Where X is the number of days. So our period is 365. So you can find the amplitude, you can find the period, how many hours of daylight are in the longest day. You use the equation we went over today for that. The shortest day, and you're going to graph the function. Start with the phase shift and graph the function. So
That's the homework for tonight.
that's the homework that's due Tuesday. Okay, so I thought it would help to just realize that this is factored here. So that's our B, and this is our phase shift. You really get messed up if you didn't realize that was already factored. Okay, so you should be able to plot that with the amplitude, period, and what are you going to use? I'm trying to find the page. We're on 4.6. Oh yeah, here it is. To find the max, this is that page where we gotta use these formulas to find the max and minimum value. So you should be able to do that. All right, so we're gonna start 4.6. So I'm going to get out of this Nearpod. All right. I got it. I'm going to stop the integrity, start again.